A fabless team taped out a custom RISC-V accelerator on a 5 nanometer node. The Verilog simulated cleanly, it passed regression, it passed lint. 6 months later, under thermal throttling and high bandwidth traffic, the chip deadlocked. The mask set $10 million was scrap. One race condition had survived every test. Veriprajna's premise is brutal and indivisible. In hardware design, syntax is not semantics and plausibility is not correctness. The wrapper era cannot survive contact with 5 nanometer silicon. Only 32% of designs hit first silicon success today. The remaining 68% require a Respin. Probabilistic tools cannot meet deterministic physics on hope alone. The cost of being wrong is now $10 million per attempt. Large language models are stochastic token predictors. They do not understand circuit topology, timing closure, or metastability. They predict the next likely token from statistical correlations in their training data. That training data is dominated by Python, Java, and C++ imperative sequential languages. Verilog is the opposite. Verilog is declarative and concurrent. Every always block, every assigned statement executes simultaneously, so the model writes Verilog as if it were C. It misuses blocking assignments where non-blocking are required. It hallucinates a XI handshake order. The code compiles, the lint passes, the chip hangs the moment it touches a compliant memory controller. Veriprajna's answer is a neuro-symbolic loop called the formal sandwich. The neural layer is the creative, a fine-tuned model that handles intent and generates code. The symbolic layer is the critic, a satisfiability modulo theory solver Z3 or CVC5 that judges the code with mathematics. The loop runs in 4 stages. First, dual path generation, from a single specification. The model emits 2 artifacts in lockstep, the Verilog implementation and a system Verilog assertion that encodes the same behavior as a formal property. If the spec says grant follows request, the model writes the finite state machine in the assertion. Request implies eventually grant. Second, the symbolic judge. The solver bit blasts the design. It converts every flip-flop, every gate, every register into one massive Boolean formula. Then it searches the entire state space. Not a sample, not a regression, the entire space. Third, bounded model checking. The solver explores 50 to 100 cycles deep, hunting for deadlocks, starvation, and race conditions. The verdict is unambiguous. Unsatisfiable means the property is mathematically proven. Satisfiable means the solver found a sequence of inputs that breaks the design, and it returns the exact waveform that exposes the bug. Fourth, counterexample guided refinement. The breaking trace is fed back into the model as a structured prompt. The model rewrites the offending logic. The solver rechecks. The loop closes only when the design is proven, not when a human engineer gets tired. The economics enforce this discipline. Industry calls it the rule of 10. A bug caught at the RTL stage costs about $100 to fix. At block verification, $1,000. At system emulation, $10,000. Post-silicon in the lab, $10 million. The mask set is gone. In the field, $100 million in a class action lawsuit. Each stage is an order of magnitude more expensive than the last. At the 5 nanometer node, a fresh mask set costs between $10 and $20 million. Only 32% of designs achieve first silicon success. A 6-month Respin can erase half of a product's lifetime gross profit. Formal verification has already caught the bugs that simulation could not. Axiomize found a deadlock in the IBEX RISC-V core, where a debug request during a branch instruction could freeze the pipeline. The same approach exposed an XI starvation bug in the Pulp platform, a liveness failure that standard simulation test benches simply do not trigger. These were proven, not stumbled into. This is the transition from computer-aided design to computer-automated design. In the Veriprajna platform, autonomous agents collaborate. An architect, an RTL coder, a verification engineer, a manager, each constrained by formal properties before any code reaches a human reviewer. The target is not faster typing. The target is zero bug silicon bugs that are mathematically impossible inside the assertion envelope. Veriprajna is not. It is not a chatbot, it is a formal verification foundry, the speed of artificial intelligence with the certainty of mathematics. A chip designer can pick a chatbot and hope, or pick proof. We named this paper the Silicon Singularity. Bridging the chasm between probabilistic AI and deterministic hardware. Read the 15-page brief, 20 minutes. The race condition that has never been caught is already in the trace.